Hi, this is Sung and I'm the Principal and Director of Sky Academy, and in this episode what I want to do is look at an aspect of multiplying, but more importantly dividing fractions, and that is rationalizing the denominator. More often than not, it is convention to rationalize the denominator. I'll explain what that means in a second, but when you have fractions involving surds, it is recommended that the denominator be rationalized. And you do that as follows, alright? So you got root A over root B. What you want is to get rid of the root bit on the bottom. And you do that by multiplying root B by itself. But if you multiply root B by itself on the bottom, you have to do the same thing on the top to keep the fraction equal to itself. Alright? So you got root A over root B times root B on top and root B on the bottom. The root B times root B gives you B. Root A times root B gives you root AB. So see how the bottom doesn't have any square root signs anymore? That's what I mean by rationalizing the denominator. So let's have a look at 3 examples here and see how we might rationalize the denominator. I'll come over and stand on this side so you can see. So square root of 2. Okay. Now, what we're going to do is we're going to multiply the top and the bottom by the square root of 2. Square root of 2 times square root of 2 gives you 2. The square root of 2 times 1 gives you root 2. So 1 on the square root of 2 is better off expressed as the square root of 2 on 2. That's a better way of expressing it because the denominator is rationalized. Got that? Let's have a look at this one. The square root of 2 on 5. Now the square root of 2 on 5 is the square root of 2 on the square root of 5. And what we can do is multiply the bottom by the square root of 5, and we need to do the same thing on the top to keep the fraction equal to itself. Square root of 2 times the square root of 5 gives you the square root of 10. All on square root of 5 times 5. The square root of 5 is 5. Does that make sense? The last one I'm going to do is slightly different, okay? Square root of 5 over 3 root 2. Now, all we want to do is get rid of the root 2 bit. So instead of multiplying by 3 root 2, what we can do is multiply by root 2 on the bottom and by root 2 on the top. And by doing that, that's enough to rationalize the denominator. The square root of 2 times the square root of 2 is 2 times the 3 gives you 6 on the bottom, and the square root of 5 times the square root of 2 gives you the square root of 10. Got it? So that's how you rationalize the denominator. I want to step over to this side now because I want to look at what you do when the surd on the bottom is expressed as a sum or a difference, either of a rational or an irrational and a rational component. Okay, 2 irrationals in one case, or a rational and an irrational. It doesn't really matter. When you do that, when you see that, what you've got to do is multiply both the top and bottom by the conjugate of the bottom. Now, what do I mean by a conjugate? Conjugate is basically, if you see square root of 3 minus the square root of 2, the conjugate would be the square root of 3 and the square root of 2 expressed as the opposite sign of the minus, a plus. That's the conjugate. What would be the conjugate of the square root of 3 minus 2 root 2? It would be root 3 and 2 root 2, but what you do is express the minus as a plus, and there you have it. That's the conjugate. Does that make sense? So what you've got to do is take each of these and multiply by the conjugate. So we're going to multiply this by the square root of 3 plus the square root of 2, and the square root of 3 plus the square root of 2 on top to keep the fraction equal to itself. 1 times all of that is just the square root of 3 plus the square root of 2, all over. Square root of 3 times the square root of 3 is 3. The square root of 2 times the square root of 2 is 2 and then minus each other. And remember how I said in the last episode, the irrational components will cancel each other out. So square root of 2 times the square root of 3, the inside 2 would be negative square root of 6, and then the outside 2 would be the positive square root of 6, plus and minus the square root of 6 will cancel each other out. So what you're left with is the square root of 3 plus the square root of 2 all on 1, which will just be the square root of 3 plus the square root of 2. Let's have a look at this example now, because we're going to do the same thing. We need to multiply top and bottom root 3 plus 2 root 2 and root 3 plus 2 root 2. Okay, so what we're going to be doing is multiplying the top and bottom by the conjugate of the bottom. When you do that, the square root of 3 times the square root of 3 would be 3. The square root of 3 times 2 root 2 would be 2 root 6. The square root of 2 root 3 times 2 root 2 times the square root of 3 would be 2 root 6 again. And 2 root 2 times 2 root 2. 2 times 2 is 4 times the square root of 2 squared would be 2. So 4 times 2 would be 8. All on. And we don't have to worry about the inside and the last two because they will cancel each other out. Square root of 3 times the square root of 3 is 3, minus 2 times 2 is 4, times the square root of 2 squared is 2, which will be 8. Okay? So the answer here will be 3 plus 8 will be 11, plus 2 root 2 plus 2 root 2 is 4 root 6. 3 minus 8 will be negative 5. Alright? So that will be the way that you do the sort of surds, the surd fractions where the bottom is a sum or a difference. You multiply by the conjugate, and by multiplying by the conjugate, you ensure that the denominator is rational. Okay, well that concludes our chapter on, or our topic of basic arithmetic. We're going to now launch into the main part of this course. Thank you very much for watching.